So today we are doing the concept of supremum. So first we need to understand supremum and least upper bound. Two words we need to understand. One word is supremum and one word is least upper bound. Least upper bound. So what is supremum? First I explain this. Suppose S is a non-empty set which contains 1, 2, 3 element, subset of n. I take this subset of n. Then what is the supremum? Then what is the supremum of S? So supremum is the most super element in S. You see here you easily find the 3. 3 is the biggest number. That is the supremum of S. Now with the same example we understand the least upper bound. First we need the upper bound. I ask you, what is upper bound of S, where S is 1, 2, 3. Now see, upper bound is which exists in S is 3, but you see there are, because this set is subset of n, so other number of S other than S which fall in n also upper bound. Like upper bound of S, the answer is 3, 4, 5, so on. All are the upper bound. Now our question is least upper bound. So these are the upper bound, and then easily you can say least element among the upper bound is 3. So the least upper bound and supremum are same thing, but supremum we said we go from left to right, and least upper bound we come from right to left. Now one more example. If I say S is an interval, suppose S is closed interval 1 to 2, subset of R, then what is the supremum of S? What is the supremum of S? So easily supremum of S can be located. The biggest element in S is 2. Now what is the least upper bound of S? First we check the upper bound. Upper bound of S is 1, 2, including 2 up to infinity. All real numbers are upper bound. Now we are checking the least upper bound of S. So this is the upper bound set interval, and out of this the least we take, this is 2. So this is least upper bound. So how we define? Now this is the basic idea of least upper bound and supremum. They are same thing. Now we need to define what should be the definition mathematically, how we express the word in the mathematical stenography. You say, what is the supremum? So let the definition, let a non-empty set, subset of real number, subset of real, then any real number u belong to R is called supremum of S. Number one condition, all x belong to S be such that x is always less than equal to u. If u is element of S, then equality will hold, otherwise it is less than. Second part, this is one part. If there is any v less than u, then there exists some s or some x in S such that v less than x, v less than x. This means geometrically, if we try to understand this saying, suppose this is on real line set S, this is 1 and this is 2. If I take S is interval 1 to 2, then u is the upper bound. That means here in this case u is 2, and if there is any v smaller than u, any v, suppose you can say take v is equal to